Hi guys, today we're doing container with most water. I was actually going to do this problem a couple days ago because I think it was the daily challenge a couple days ago or something, but got really busy with midterms and ended up not being able to get to it until now. So we're doing it now instead, even though it's a couple days late. But we are given an integer array called height of length n, and there are n vertical lines drawn such that the two endpoints of the ith line are I, 0 and I, height at I. So they want us to find two lines that together with the x-axis form a container such that the container contains the most water, and they want us to return the maximum amount of water a container can store. They say, notice you may not slant the container, so we can't have any diagonal lines or anything like that. So if we take a look at example 1, we are given this input array of heights, and we would output 49, and that is because, so I've copied and pasted the array over here so we can look at the indices as well, because it's a little bit confusing if we look at it from here, because it looks like 0 starts from here, but it's actually from here in the array. I don't know why they did it like that, but it is what it is. So, basically, if we calculate the area of this rectangle here, we get it by doing the index of this line minus the index of this line. So the last one is going to be index 8 because that's where the 7 is, right? This one has a height of 7. And then the second one is this one. So if we do the indices, so 8 minus 1, that gives the 7 for the base. And then area is base times height. So the height is going to be 7 as well, because the length of this is 8, the length of this is 7, but we have to take the minimum of the two because otherwise, if we take the maximum, the water is going to pour over the side of this line, right? And so we can't have that. So we have to take the minimum, and that's just how much water we can store. So 7 times 7 here is going to give us 49, and that is how we get the maximum amount of water. Example 2, the height array is this, and we would output 1. So they don't give us a diagram or anything, but if we just imagine we have this line, but let's just pretend this 8 is this line again, but here, right? Then we get the base by doing, if this was a 1 instead of an 8 and we didn't have the rest of this, just imagine, then we would take the index of this, which is 1, minus the index of this, which is 0. So 1 minus 0 gives us 1 for the base. And then the minimum of the two heights is 1 because they both have a height of 1. So 1 times 1 would give us 1, and then that's how we would output 1 because that would be the area. So yeah, basically how we're going to do this is we are going to start by, so we're going to have 2 pointers actually. So we're going to start by having one pointer all the way on the left side at index 0 of the array. The other pointer is going to be all the way at length minus 1 of the array, which is this one. Let's just look at example 1 as we go through it. But we are going to start here, and then our area, we are going to keep track of the area as we sort of move our rectangle around to see what our maximum can be. So we're going to keep track of the current max at every point. And then once we're done checking through everything, then our current max will be the actual max, and then we can return that. But basically what we are checking for, so we're going to start again from the 0th index to the last index. Get this area by doing the base and then times height, and again we get the base by doing the index of the last one minus the index of the first one, and then times the height, and the height is going to be the minimum of the two lines. And then whichever line is shorter, so if we look at the first and last one to start with, this line is shorter. So we obviously want to get rid of the shorter line if we had to pick, because we want to maximize the amount of area that we can possibly get, right? And so we want to keep whichever line is longer and then get rid of the shorter one in hopes that we will reach a longer line next. Does that make sense? So if we start from here, we'll get rid of the shorter line after that and then move this to the right, and then this line is much longer, so this already increased the area by so much. And then we just go back and forth, whichever one is shorter. So if it's the left one, we'll move it to the right after, and if it's the right one, we'll move it to the left after, and we'll keep shrinking this window until we reach the point where the left one equals the right one, so it'll hit the middle or something, or let's say I guess from here, so this will move here, then this one's shorter, so it'll move here, and then this one's shorter, so it'll move here, and then these look about the same. Oh yeah, they are the same. So I guess whichever one's shorter, you can just tie break however you want to tie break. So let's just say we move the left one, move it here, and then this one's shorter, so we move here, and then here, and then here, and then here. So it'll end up here, for example, right? And then at this point, it doesn't make sense to calculate the area of a line. Yeah, because you can't do that to get area. So like we would exit out of the loop and then just return the max at that point. Does that make sense? I hope it makes sense, but let's just start implementing it. So we first need to keep track of our maximum area. So we're going to make a variable for that. So we'll say int max is 0. And then we need our 2 pointers that we are going to use to keep track of which indices we are currently at. So we have left, which is 0, and then we have right, which is going to be height.length minus 1. And then our condition is going to be while left is less than right, because again, that when they're equal, that is the point in which it becomes just a line. So while left is less than right. Then we are going to calculate the base, and we're going to do that by just taking the index of the right line minus the index of the left line, and that will give us the base. So int base is right minus left. And then we're just going to get the area. So we're going to update the maximum area from the current max, which right now is 0, so like literally anything is going to be more than that because we can't have a negative, or the area that we currently have with these 2 lines. So we'll just update that. So max equals math.max, and then we'll put max as one of them, and then the other one is going to be what we are calculating right now with these 2 lines. So the area will be so we're going to take the minimum of, let me think. Okay, we're doing, well, base times the height, and then we need to calculate the height now, actually. So the height is going to be the minimum of the 2 lines. So we're going to do math.min. And then to get the line, we are going to just access, like the height of the line, I mean, we're just going to access the elements directly from the array. So height at left and height at right. And that will give us the 2 heights. We'll take the minimum of these, which will be the height, and then we'll multiply it by base to get the area, and then, yeah. So then we need to do a quick check to see which line is shorter. So whichever line is the shorter line is the one that we need to move over, because we want to get rid of it, right? So if height at left is less than or equal to height at right, and again, you can break ties however you want. Like you can also just say like less than height at right, because if they're the same, then it doesn't really matter which one you move over. But if this is the case, then we will increment left, because if left is shorter than right, like it was in this case where we had the 0th one in the last one, then we want to move this one over to the next one, right? And then if it's not, that means the right one is shorter, and so we'll want to move the right one to the left by doing right minus minus. And then we're just going to do this for every single element in here, and then we're just going to return the maximum area. So let's run this. All right. So our time complexity is going to be O of n, where n is the number of lines in height. Because we're just doing basically one pass on each of the lines in our height array, right? Because we never actually do more than O of n. I think actually, yeah, every time we do exactly like pretty much O of n, because we start from the entire array and then we work our way towards the middle until, or not in the middle, but like, you know what I mean? Like towards the middle, even though it might not end up in the middle, but it just depends on the heights of the lines. But like we're always visiting every single element exactly once. It's just might be out of order, but that doesn't matter. Our time, and then our space complexity is going to be O of 1, and that's because we don't use any additional data structures here. So that is it for this problem. Thank you guys for watching, and I'll see you guys next time. Bye!